So I'd like to go over the escape room activity because there are a lot of little parts to it that, like I made sure to go through it a couple times before I started. Before I posted it. Like I pretended to be a student and answered them myself. And then I took really careful notes of what you should be looking out for in terms of don't miss this instruction, don't miss this part, don't miss this part, don't miss this part. I also mentioned in some of those other videos, if you watched them, if you needed them, you might not have, but the idea of you're not just finding the area. It's not just that straightforward. It's like, okay, now you know how to find the area. Now can you answer these questions that maybe have a second step to them? And please bear with me. This video is probably going to be a little bit longer because we have a bunch of clues to get through. I think 5, which each have their own set of problems. I'm not going to go over all the problems. I don't want to give you all the answers, but I want to help give you examples of what they're asking you so that when you go to attempt it yourself, or if you go back to attempt it because maybe you got stuck the first time, that you're like, oh, I remember what that means because I remember the examples. Okay, so I'm going to try not to do any of the real problems from here, but rather show you what they're asking. So, very first thing, and again, you have to be really diligent about reading the instructions. I spend hours sitting there and typing, okay, on this page, here's what you need to know. This page, here's what you need to know, da, da, da. So on the very first, in the instructions, it'll say that the entry code or the promo code on your flyer or whatever, because this is an activity that can be done in person as well, and typically you'd have like the printouts and stuff, so that's what they mean by like your flyer. But in the instructions, I did tell you that your promo code is simply A equals BH. And so there's no spaces, just the A, the equal sign, the B, and the H. That is your code, okay? And I've always done it with a capital A. I've never tried it with a lowercase a. I think my computer auto capitalizes the first character anyway. And so I don't know if it's case sensitive or not, but if it is, just make the A capital and everything else lowercase, okay? So just area equals base times height is where they got this from, but it's literally just A equals BH. There's your entry code. Now you're in and you're on the first page of the menu is what they're calling it. So they're using pizza as a way to practice these things. So on the first page, you're given parallelograms, okay? And there's a few things I want you to notice. First of all, if you remember from our class discussion or if you watched the last video, I've mentioned to you before that they sometimes give you superfluous information. And that word, here's your vocabulary word for the day. Superfluous means extra and unnecessary. Like it's basically just there. So they do that often in these problems, and they give us things like, oh, the base of this parallelogram is 12, and the height of this parallelogram is 5. And then the length of this side over here is 7. Okay? Remember, get back into the shot here. Remember that we only care about base and height when it comes to parallelograms. So we only care about this base, and then basically remember that height can just be how far apart are these two parallel lines. That's the height. The 7 is superfluous. It's there. It's true. It's not needed. We don't need it for this problem. So please be careful with that if you only need the base and the height, that you're not getting confused by this extra dimension that they're giving us. It's not meant to trick you, but it's meant to check that you really are understanding what you're doing, okay? So let's say, for example, oh, nope, I'm going to have to pick some much larger numbers. Let's say, for this first example of what you have to do on this first page. So not only is it just asking you what is the area of these parallelogram shaped pizzas, but then they're asking you how many people will that feed. Okay, so there is a second step. So your first step is to just find the area. Okay, and that's why I need to pick a bigger number because for the example, it will not work that way. So let's say we do, I don't know, the height will be 50. Okay, and then the length down here, oh no, let's make the bottom 50. That'll make more sense. And then let's say we make the height 5. I don't know, I know it's not to scale, which that's another math term. It's not to scale, meaning you might say, how is that 50 and that only 5? It's not to scale, meaning it's not proportionate. So we're just going to pretend that it is. Like most of our math pictures in our books, they're not proportionate. They're not to scale always. Sometimes they are and sometimes they're not. So here, let's say that these are the dimensions we're given. And again, you might have some superfluous information over here like, oh, well, this side is 12 and this side is 12. Okay, that's good. That's great. Congratulations. But we don't need that information for this type of problem. So what our first step is to do is to just find the area. And I might just take my black pen and say, cool, the area is 50 times 5, which would equal 250. Okay? So, and I think these were all in inches. So let me go back and fix that real quick. Inches. Ignore my dog growling over there. So now we have a total of 250 inches squared is how big this pizza is. Obviously that's a pretty big pizza, but so this is step 1. 250 is not our answer to the whole problem. It's just the area of the pizza. Okay, that's just the first step. The second step, hush bud. The second step would now be they give you up at the top of like that page, the menu at the top of it. You know, here's your problems, your parallelogram shaped pizzas. And at the top in the writing, you have to read that really carefully. They give us the information that if 100 square inches of pizza feet make one person feel completely full, how many people would feel completely full eating this pizza? Okay, so if this pizza, and again, this is not one of the real problems on there, but it is the how to do this type of problem. If there's 250 square inches of pizza and 100 square inches feeds one person, you can reason this out however you want. Basically, we're taking that 250 and we're dividing it into groups of 100 because each group of 100 inches of pizza, square inches of pizza, makes one person full. So what you might do, so some of you can look at that and go, well, there's two groups of 100 and then there's a group of 50. Okay, so you might be able to reason it out, but if not, you can draw a picture, do whatever you got to do to say, okay, well, this number is made up of 100, 150. Okay, 100 square inches makes one person feel full. So really, we only have 2 people getting full off of that pizza because the 50 square inches that are left over does not make an extra does not make that third person full, and we only care about how full is that, how many people, are going to be full from this pizza. So 250 square inches, sure, we're going to have extra pizza, but when we're asking the question how many people get full, only 2. Okay, now on this page, first of all, we're in middle school. I will tell you for this, if your parents let you, I'll leave it up to them, you may use a calculator because we're not worrying about your multiplication at the moment. We're worrying more about, do you know how to do this? Okay, and as you get older through middle school, you'll use that calculator more often and focus on the concepts more, okay, than you maybe did when you were in like 4th or 5th grade. So on that page, on that menu, they give you 3 parallelograms, okay? So like for this one, for example, again, it's not on your paper, but for example, it would be feed 2 people. So you'll have basically like this. It doesn't have the dots or the dashes, but you're going to have 3 problems that each have their own answer, right? So this pizza, say, would go here, and then the next pizza here, and then the next pizza here. They have to go in order of the pizzas. The pizzas are numbered. Pizza 1, pizza 2, pizza 3. So you would take your 2, right? Because we're just saying how many would be completely full. Only 2. And that goes in, like, let's say this was problem number 1, which again, it's not, but let's just say it was. Then my 2 would go right there. Then I would solve problem number 2, and my answer would go right there. Then I would solve problem number 3, and my answer would go right there. This is the code that gets you to the next page. So you basically have to answer each pizza correctly, and you have to understand what you're being asked and enter those in order with no spaces. Again, the instructions are pretty clear at the bottom. It'll say, like, do not enter spaces. And And if it's wrong, it'll tell you it's wrong. You have to kind of reevaluate and say, wait, okay, where did I go wrong? Am I putting this number or this number? Did I maybe do a calculation wrong? Did I use a 12 and I shouldn't, use a superfluous number and I shouldn't have? You kind of have to troubleshoot from that point forward. Also, don't forget that I would love to see your work. In fact, I'm requesting your work. So the easiest thing you could do, so say for example, you have your papers like this, you could simply take a picture on your phone and then email it to yourself to put it on your computer and then upload it into the assignment when you submit it. Or if you have Google Classroom on your phone, you can take a picture and upload it straight into Google Classroom just straight from your phone. Like it'll let you look through your phone pictures. And if you need help with any of that, if you have a scanner, that's even better. I need to just see it. I don't have to touch it. I don't have to feel it. I just need to see your work. Okay. So, keep it. And if you're still stuck and you don't know how to do it, then just keep it in one place and eventually we'll figure it out, a way for you to do that. Okay. And eventually, I don't know when, but the school's gonna have cutback hours, but eventually you can drop things off there for me as well. It just might take me a while to pick them up because some of the virus germs can live on paper for an extended period. So we like to take a break between switching hands. Okay, so there's your first menu page. Okay, so you have to solve for the square inches. I think they're all in inches, square inches, and then divide this number by 100 because that's what they've told us is that 100 square inches of pizza fills up one belly. So we're saying how many bellies could we fill from this? Only 2. We could half fill one, but that's not what we're being asked. How many full bellies? So 2. Okay, and then problem 1 goes here, problem 2, problem 3. Okay, good with that? Now, we're moving on to the second page. So if you get it right, it'll just auto take you to the second page. If you don't, you got to stay there and figure out what you've done wrong, or ask me or ask a friend or a parent or a sibling. That's a great thing about having siblings home if you have them, is that sometimes they can be helpful to you. So there's page 1 or menu 1. The next page jumps to trapezoids, and this one again is somewhat straightforward in you just solve for the area, and then this one they do ask you a second step, just like the last one was asking how many bellies are full. This one's asking how many tomatoes are used on the pizza. So say for example we have and of course I did not come up with a good example. That's not one of your what if we do, that would be 6. Oh well, I'm just gonna do the first example. I just want to make the numbers work well, and this is the easiest way to make it work well, is to just pick an example. So sorry, I'm doing one example, and then I might do some of the triangle examples because those ones have this extra challenge bit to them that we'll go over when we get there. So here's a trapezoid they've given us. If you remember your areas of trapezoid, I take my base 1, I add my base 2, and then I multiply that by half of the height. Okay. I look here and say, oh look, half of my height is 12, so therefore half is 6, and then my base 1 plus base 2 makes a 20. And then I multiply those two together, which if you know your 6 times 2 is 12, and then the 0 carries over. So we get 120. Now, the thing that they have prompted us, this is our area. I believe this was inches too. I'm sorry, I'm not being great at that. I'm also trying not to make this video take forever for your sanity and mine. So here's my area of this pizza, right? Now, this is the total area of the pizza, but you have to read those written instructions at the top. It asks you, it says, if 1 tomato covers 12 square inches of pizza, how many tomatoes does it take to make this pizza? Well, here's my square footage, or square inches. So if there's 120 square inches of pizza and one tomato covers 12 square inches, so basically I'm taking this number and I'm cutting it into chunks of 12 square inches, which we're dividing this equally into groups of 12 inches and knowing, oh, that group of 12 inches, 12 square inches is one tomato. That group of 12 square inches is another tomato. That group of 12 square inches is another tomato. So we have to figure out how many tomatoes. So we're basically taking the total and dividing it into equal groups of 12 to see how many tomatoes it took to make that pizza, because we know that for each group of 12 square inches it took one tomato. Okay, so if I were to do this guy and say how many groups of 12 are in 120, I'm not going to tell you the answer. Hopefully will be sort of straightforward for some of you. And then at the bottom of that page, again, you have, I think, 3 pizzas, 1, 2, 3, and it tells you to enter it with the little dash in between. Okay, I'm 99% sure that's the page where but it tells you right there. It says put a dash in between your numbers. So you have to type the hyphen. You type the number, type the hyphen, type. So these ones might be like 2-digit numbers, and that's okay as long as you put the dash in between the answers and then hit next. That should take you to the next page, assuming you did all that part right. Okay, so find the square inches, find the area, and then you have to divide it by the information that they gave us, which in this case was 12, in order to find how many tomatoes. Okay, so that's the second page. Now, on the third page, I flipped my paper for that one. Oh, the third page is the triangles. Okay, so I'm going to let you do, I think there are 7 triangles. Yeah, there's 4 and 3. The 4 on the left side of the menu are just find the area. So I'm not really going to go over that because you can watch the area of triangles for that part, and then basically solve them and set that number aside. What you might want to do is literally have a fresh piece of paper where you're only writing the answers. And I'll tell you why in a second, because then you have to use those numbers for a code, okay? So there's 3 problems, however, where they tell you the area and you have to figure out what the dimensions are. So let's look at one example. And this is one I will do straight from the page, because like I said, this is a little bit trickier of a skill, and having just started working with these shapes, these polygons, I understand how tricky it is, so I want to help you through that. So the first one says our height, I don't remember if these were inches or, yeah, I think they're inches. And then it tells you X. So remember that a letter like that, an X, which we call a variable, just is standing in for something that we don't know what it is yet. Okay, but we're going to get down to it and figure out what it is. And then they tell you that the overall area of this is 15 inches squared. So we have to take what we know and kind of think backwards. We know our final answer, and we have to figure out how did we get there. And if you remember, area of triangle is 1/2 base times height. So basically, when we get our answer, our area, it's been cut in half. It's half of what our base and our height were, right? So right now, I would say, 15 is this area, but how do I think backwards from that, right? Like, how would I, and basically, when I multiply, if you remember back to the video about triangles, this idea that 2 triangles make a parallelogram. If you can see the outside shape right there, that's just a parallelogram. So that's the base times height, meaning if I multiply these 2 numbers together, I should get double what my triangle is, okay? And if I'm looking at this and I'm saying, okay, well, if this little guy, maybe I'll switch colors so I don't mess myself up too bad. I say if I already know that this area is 15 and I have another one, then I know that that area has to be 15 also, right? Because that's the whole point, is we're doubling it. It's the exact same triangle. We duplicated it and we flipped it upside down and we lined it up. So basically, if I think in terms of a parallelogram, okay, my base times my height is really double the area of my triangle. So if my triangle is 15, then the area of the whole parallelogram should be 30, okay? Which means I'm now having to stop and say, wait a minute, when I take 5, right, because 5 is my height, my base is, I don't know yet, and then when I cut that in half, I get 15. Which means I need to think backwards and say, but when I double that, I get 30, right? Meaning instead of dividing by 2, if I multiply this by 2, I doubled it. Now I'm saying what times 5 equals 30? Right? Because I would take my base and my height and multiply them together. Well, that's a parallelogram though. That's this big thing. And then I cut it in half and get 15. So if I go backwards, then I'm going to double it and get 30. And now say, well, 5 times what gave me the 30 that I cut in half to get 15, excuse me. So what times 5 gives me 30 in order to cut that in half to get 15. So therefore, what I recommend to you is to take your area and double it. Then your base times your height should equal 2 times your area. Meaning this base and this height should equal 2 of your areas, okay? So in this case, question mark or X. How about we switch this to X and use the dots because that's a little more mature for a middle school class. So our base was X times 5 equals 30. And now, which you can see over here, now we basically just need to reason this one out. And you can divide or you can just use what you know and say, oh, 6 times 5 equals 30. So then this has to equal 6. And if you're not sure and you're like, I think that's right, just check it. Now go back, now apply this normal and say, oh, well, 6 times 5 is 30. If I cut 30 in half, I get 15. So that has to be right. Okay, so you have to think backwards. When we were learning the area of a triangle, we said, well, what if we take a parallelogram and cut it in half? Well, now you're taking the area of a triangle and doubling it so that you can reason out what was multiplied to get that parallelogram to start with. And then you cut it in half. So take your area, double it. So for example, how about I write the next example up, but I'm not going to solve the whole thing because, again, I want you practicing this. But the example that looks like this, there's this tall, skinny one, and it tells us that that the base is X. This is a find the base one again. Base is X, height is 8, and the total square inches is 4. So if I were to think backwards, I say, wait a minute. The base times the height, that's not right. Gotta come out a little farther and then come back down. The base times the height, these two numbers together, X times 8, would give me a parallelogram, which would be 2 triangles. If one triangle is 4, then 2 would be 8. Okay, which now I just need to reason, okay, well, what number times 8 equals 8? And I really hope that we know that one. So, double your area and then reason, well, 8 times this gave me this double one. Because remember, we cut it in half to get the triangle, which half is 4. So we have to go to the parallelogram first and then say base times height equals the parallelogram, which is 2 of those. Okay. And then on the last one, it's the same thing. It's just a right triangle now. Okay. And again, I'm not going to solve it for you. I'm just going to show you, what you would do with those numbers. So here is the right triangle. It goes this way. And then it tells you the bottom is 4, the height is X, and then the total is 26 inches squared. So again, I would start by saying to myself, well, wait a minute. If I multiply base times height, I get a rectangle or a parallelogram, which would be double this area, because this is just the triangle area. Double that area. So then I say to myself, okay, 4 times, nope, I want to use my X, I'm going to use the dot, is equal to double that, which 52. Okay, and then I can reason backwards from that and say, well, what does that have to be for that to be true? Okay, so there's the triangle page. Yeah, that's only page 3. Then, but that's why if you notice, there's a lot of, I know that this is going to take a minute, you know, there's a lot of steps, even for me to do it on paper. I'm like, oh, I got to sit down and write it all down and do all the things. So, that's why this is one of saying that you have a week to do. And if you need more time, please let me know. I'm not going to penalize you because something was hard for you. You know, that's not your fault. Buddy! Stop! He's not going to stop because the neighbor pulled in across the street and he likes to bark at everything outside. So, he's, yes, the smallest, yippiest dog in my house. All right, so let's see, 1, 2, 3, that was the triangles. Now 4 was the composite figure, which we had not done yet. But again, I have faith in you that we can do this together. So I'm gonna try my best to draw it and draw it quickly. It's like you're in class, right? When you have to wait for me to draw all my things. And again, this is not going to be to scale, so forgive me if my numbers don't match my dimensions. Alright, that wasn't too bad actually. Alright, so it kind of looks like a skyline to me, like the shadow of buildings in a city or something. So they give us, and I'm going to write in black the dimensions that they tell us. Okay, and then I will change colors for the ones that we have to kind of figure out ourselves. And you might want to have this video open or playing while you're working on it, just because these numbers are hard to see. So if you're looking at the actual Google form in another window while you're watching this, it might be easier because you'll be able to see the numbers a little bit clearer. And again, I think that's what they've given us. All right, so now we have to decide how are we going to cut this shape and how do we reason out what some of these unknown or unlabeled dimensions are. So, and I have my notes from when I solved it. I literally just did it on paper myself because that's how I like to do it. So what I first noticed is, wait a minute, this is a triangle right there that, like, that has to be by itself because that's the only triangle, that's the only way to cut it and make it a triangle. And I can see that there's this nice little tiny rectangle right below it, and that will help me as I go to do the rest of it. And now if I kind of look, the rest are really just rectangles, which is pretty nice. You don't really have to do a trapezoid, just rectangles, which are parallelograms, and one triangle. So if I were to look up here, here's how I might cut it if I were you, or how I actually did it when I was working on it. So I might first try to cut it right here and say, well, wait a minute, that's just a rectangle that's 8 by 13, and I know how to find the area of rectangles. You might then say, well, I could do that as a rectangle, but here's where it'll get tricky. It works. This is the way we're going to do it, but I just want to give you the little foreshadowing that this is a little tricky. So, I already know that the length of this whole side right here is 8 plus 5. If you remember me telling you those parallel lines, they can just be dropped down right next to each other, and then so like my 8 and my 5 are only separated by the connecting line, but they really, if I got rid of that line, would touch, and then they would just be one combined length. So if this side, so here's what I'm going to do. On the inside, I'm going to label in red, and hopefully if you, depending on what computer you're using, if you have a bigger screen, you might be able to see it better. I don't know, but I'm just going to make my dimensions on the insides of the shape. So 8 times 13 will give me that rectangle. Then here we've got 8 plus 5, because this red line's 8 and then that line's 5. So 8 plus 5, 13. I can label this side 13. Now it's this short side here that's going to get a little tricky, okay? The way we have to reason this one out is now looking at these vertical lines, okay? And I'm going to use a different color just temporarily, and then I'll erase it, but just to kind of highlight what I'm talking about. This line right here is a total length of 37, and it should match up to all of the horizontal lines that are parallel to it, meaning the length of this line, the length of this line. Nope, that's the one we don't know yet. Well, yeah, okay, that's the one we don't know yet. So this is the one, it should, sorry, and then, I was getting confused by that 3, but that's irrelevant right now. And then this line 17 over here. If I were to slide this one over and slide that one over, they would line up and be exactly the same length as this 37. And you can hopefully see that as if you kind of imagine things coming together here. And that's the only one we don't know. So guess what? These 3 here should equal up to 37. So if I look at what I have so far, is I have 17 and I have 13. That one's 13 and that one's 17. If I add those together, nope, just kidding, I can add. I get 30, and this side is 37, which means guess what? 7 are missing from this side, which means that this dimension right here would end up being 7. So I'm going to use my red again. Okay. So now I've got 2 rectangles. Why do I feel... Oh, no, I got it. Okay, so I've got these 2 rectangles, right? And then I am going to show you that I did this giant rectangle, meaning this big old rectangle right here. Now, I know already on this side that my dimension is 17 because that's the length of this side, and that one's clearly labeled. Now, the bottom one is a little bit trickier, but now with my green, we're going to show how all of these dimensions that don't overlap. So if you notice when I did the blue, I didn't count these 3 because those ones overlap with this blue line. So they're not being put in